Welcome back to the video lecture series on statistics in my machine learning. So this is Amit Kumar Das. We have already gone through different measures of central tendency and different measures of dispersion. Like for central tendency, we went to mean, median, and mode. And for central tendency, we went to the three measures: standard deviation, mean deviation, and quartile deviation. Right. So that was all the theoretical stuff, though we have kind of understood it in a very simple way, but there are more complex or other more advanced concepts related to that. But we just wanted to get the fundamentals of the concepts. Now we have the concept, so we will start delving the things in the machine learning perspective and using the Python code, right? So whatever things we have seen, the concepts of mean, median, mode, and standard deviation and all, let's try to see the same things in a standard machine learning data set. Okay, so what we will do is we will first start with importing some of the standard machine learning, Python libraries. Like the first one we will import is import numpy, right, as np. Then we also will import another very important library for data processing, which is the pandas library, right? So pandas as pd. And then we will also import one more very important library, which is related to the plotting, the graphical plotting. So what we have seen is all the theoretical stuff, right? The same things can be seen from a graphical perspective, right? So we will do that. So let's start with importing these three libraries, right? So once we do that, then the next thing we're going to do is we will have to import a data set, right? So for that, we will first copy our data set to our Google Drive and then import that in the Google Colab. So we are using Google Colab, as you can see, right? Then we will import it in Google Colab so that we can load that data set, right? So let's do that. So we will do that from Google.colab import drive. So we will do this first, and then we are going to have this drive uploaded, right? So we do the mounting of the drive. So once we do this, it will ask for, the credentials, right? So I will need to give a permission authorization code using my Google accounts, right? So let me do that first quickly. And this is how I do that. I copy the string and then I paste it here, right? And once I do this, it will allow me to uh, mount my drive, the Google Drive from Google Colab. Next, what I do is I have to upload the data set. So let's try to do that. So how do I do that? I use the pandas command, read.csv. Let me do that. So I will use my file. There is a file called wine quality data. That is wine quality. So that's a file which is available from the famous machine learning repository, which is the repository of University of California, Irvine, UCI repository, we call that. Sorry. So we just load that CSV file from the Google Drive, right? I do that. And once I do that, I can also see the content of the file. Okay, so how do I do that? So basically data dot head, right? And when I do that, I will get the data set, the first 5 rows of the data set, right? So these are the different attributes or the different columns which are there in the data set. Now what do I do? Now say for example, when we studied the different central tendency, the measures of central tendency or the dispersion, that is based on a set of observations. And what is a set of observations? Basically, for a particular attribute, there is a set of observations, right? So when I apply these concepts of mean, median, or mode, I have to apply on a specific attribute, right? So I have to do that. So let me do that. So let me retrieve that attribute. So let me retrieve that attribute as X. Okay, and I simply do it using the column name. So I just use the column name fixed acidity. So I just use that column name to fetch the data, right? So once I do this, I can also see this one. Okay, so let me just run this thing. So I have got all the things now. Now, on this X attribute, which is basically nothing but a set of observations, I can tell that, right? If I run the different statistical measures, say for example, I use the numpy function mean, right? np.mean, and I do that on X. What do I get? I should get the mean value for this attribute fixed acidity, which has been saved as X, right? Same way, I can also basically find out the value of the median, right? How do I do that? np dot median, right? And then I do the X. Same way, right? I'm sorry, this is a misspelling, so that's why it has thrown the error. So I do the same thing, 7.9. So mean is 8.31, median is 7.9, right? Now say I want to measure the standard deviation, right? So how can I do that? So NP, either we can do the variance and do a square root of that. So NP dot var, okay, and then I give a X. So this will give me the variance of X. So that is 3.029. And the same thing if I do standard deviation, STD, I believe that is the, yes. So STD is the function, standard deviation, right? And I give this X, same X. What do I get? I get the standard deviation. Just do one thing. Just make a square of this, okay? So make a square of this. See whether it's matching with the variance or not. I'm sorry. This is not the proper way. So I'm just going to give the 2. Right? So it's going to be the same as variance. Obviously, it's got to be. Right? So this is the way I can calculate for a specific attribute. I can, and how do I retrieve the attribute? Simply by calling that the the attribute or name I can use to retrieve that attribute, and then I can use the NumPy library methods like mean or median or variance or standard deviation. There are many other such statistical methods which are there as a part of the NumPy library. You can use that and calculate the values, right? So we don't have to break our heads by doing the calculation, summation of xi minus x bar square divided by, nothing has to be done. Simply you call the NumPy function std to get the standard deviation of the variance, right? If you call it the dot var, you get the variance. If you call the dot std, you get the standard deviation, right? So this is the simple way to find out the statistical measures by using the NumPy library functions. I recommend you to go through a Python course and understand the different methods and functions available as a part of the NumPy library, right? And you can understand them, how you can do the statistical calculations using the NumPy library. Okay, so in the next lecture we are going to cover some of the graphical ways to do the same things, right? To understand the characteristics of a attribute or a set of observations using the graphical this thing tools, which is they are in the matplotlib library. Okay, so stay tuned.